Now in this example we're going to revisit a couple of models that we've already been talking about. The SES model, simple exponential smoothing, and the linear exponential smoothing, LES model. So we're going to use the Netflix data going from years 2000 2003, and this is quarterly data. Okay, and let's set up an SES model. Let's start with the alpha of 0.3. Okay, and we're going to use the first year sales as our forecast. So error will be quarterly sales minus f sub t. Okay, then previous forecast plus alpha times the error would be the forecast now. I mean for the next time period. So we copy that there. Then we can copy those two all the way down. Can put the border back. And we're going to be calculating the error measures starting from quarter 5. Okay, now let's set up the formulas for these error measures. Okay, so we're going to use C11 through C22 for the actual value and the forecast. That's RMSE. Okay, next is MAE, same range. MAPE. Now MASE, okay, same range for Y and the forecast. The random walk forecast for 2001 through 2003 would be the last quarter of 2000 to the third quarter of 2003. So that will give us MASE, and same TLU. Okay, so now we have that. Now let's run solver. Okay, here we're going to RMSC to minimize alpha, and alpha is less than or equal to 1. Solve, and we get alpha equal to 1. So simple exponential smoothing, the values are for alpha equal to 1 and MASE and TIL. Okay, now the same problem with LES model. Okay, so let's first set up the initial values. So the initial values are going to be set up there. Trend is y minus that divided by 2. Then average of these plus the trend. Now that plus that is the forecast. That minus that is the error. Now the forecast plus alpha times the error is the level smoothing, then previous trend plus beta absolute reference that times L minus F. Now we can copy that all the way down, put the border back. Now we can set up the RMSE, MAE, MAP in the same fashion as before, and that they turn out to be, so here are the formulas. So MASE tells you exactly like before. So now let's run solver to see the best alpha and beta values. We'll minimize RMSE. Now the changing cells will be these two. Delete that and add alpha beta less than or equal to 1. Okay, now solve. Now get the best values. So once again, alpha is 1 and beta is about 0.5. Now that is using RMSE. So let's copy this beta over here for RMSE. So this one is by RMSE. Let's use RMSE there. Now suppose if we run solver using MAPE or MAE as our, so MAE as the criterion, and what are the parameters? So now is it different? Well, it's slightly different. The beta is different now. So we'll use that beta, and let's see, let's try to get these values for the different beta, alpha being 1 both cases. So RMSE, MAE and MAPE, and then MASE and Thiel's U. Okay, now we can run a data table. Now beta is the only input, and that's in a row. So we're going to keep alpha the same as 1. Okay, now click OK. So now we have the measures. Okay, now MAPE is the percentage. Okay, now let's white this out. Okay, so let's compare. Now you see in this particular case, the LES model is definitely superior to SES. There is a linear trend, and you see it beats the LES model beats the random walk model very handily, and you compare the other 3 measures and you see that the LES model definitely beats SES. So for both RMSE minimization, the beta formed by minimizing RMSE or the beta determined by minimizing MAE, both of them give you very good results compared to SES. Of course, the caveat being that we don't have enough data for an analysis with the holdout sample.